In this presentation we shall look at some of the metrics available in QAC++ 3.2. We'll look at some of the new metrics, we'll look at them in QAC++, and then we'll also have a look at them in QA Verify as well. So I have a project here. This is version 6.1.9 of the GNU open source uCommon project. I've already analysed the code and I've added a metric threshold on the cyclomatic complexity to tell me when the cyclomatic complexity of a function exceeds 10. So I can go and have a look at the messages that have been produced by the analysis, and here's my metric message here, and I'm going to choose to just view that metric only. So I can see all of the functions that have produced that message. So if I go down and click on one of them, for example, I jump straight to the code which has that message related to it. So I can see for this function here, getArg, it has a cyclomatic complexity of 35, and that's quite a complex function. We can see that there are a number of decisions in here, switch statements, if statements, and some of the ifs are nested within switch cases and within loops as well. So this means this function is fairly complex, it's quite hard to understand, and if I was maintaining this function I might find it quite hard to add new functionality to it. There are 29 new metrics in QAC++ 3.2, and let's have a look at another new one now, the number of local variables defined. So I'm going to add a threshold for this one as well. So I select my C++ toolchain, and the option I want is the threshold option. So I'm going to add a metric threshold here, and I want the parser to tell me if it's greater than 5. So we'll save that, and then we'll reanalyze the project. So when I click Analyze, QAC++ is taking each source file individually and pre-processing it in the same way the compiler would, pulling in all of the header files, compiler header files, doing template instantiations if required, expanding macros, concatenating literal strings and so on, all the tasks that the compiler would do. We then parse and tokenize the code and write out all of the issues we've detected on the code. So we can just have a look at how we did there, and all of the code has been analysed successfully. So let's go and have a look at our metric messages this time. And we can see we have some for STLCT as well. So we can click on there and go and have a look. The number of local variables declared could be indicative of too much complexity in one function, or it simply could mean that you just need a lot of variables for that particular function or algorithm. That's one of the limitations of looking at metrics in a project. We just see a single snapshot. If we could see the trend of the metrics over the lifetime of the project, we can get a better idea if the project is getting better or worse, and use this information to take early action on the project. We can do that using QA Verify, where we can trend the metric and see if it's getting bigger or smaller. We can also derive compound metrics from other metrics, and also create metrics based on message counts. So I'm going to switch to QA Verify now. I've got my dashboard set up here in QA Verify. I'm logged in as Jason Masters. Everyone who uses QA Verify has their own login and can customize their own dashboard. So here's my uCommon project that I've uploaded. Let's go and have a look at the measurement analysis. So we could just go and have a quick look at the metrics we've already looked at in the desktop. So if we look at the hierarchy view, we can drill down into our project and go and have a look at particular files, and then go and have a look at all the functions within there. And over on the right hand side we can select the metric we want to look at. So in this case we'll look at the LCT, and we can click on our function we looked at earlier, and we can see that the metric for here has remained stable over the past few versions. So that's okay. And then we can go and have a look at our Cyclomatic Complexity one as well, and that was in shell.cpp. And then we have to select the metric on the right hand side, and again we can see the metric has remained steady over the history. We can see the snapshots that have been uploaded and choose to start looking at any particular snapshot, and we can also adjust the range of the history we look at. So at the moment I have 4 snapshots, and I haven't uploaded the snapshot in QAC++. So let's just pop back to QAC++ and set that upload going. So I can easily upload to QA Verify by selecting the upload option, and that will take a couple of minutes to package all of the information, connect to the QA Verify server, and pass the information up to QA Verify. Let's have a look at some of the other new metrics in QAC++. There are another 2 new file metrics, STM20, which is the number of operand occurrences, STM21, which is the number of operator occurrences, and there are 4 new function metrics, which are the number of operator and operand occurrences, and the number of distinct operators and distinct operands in a function. Now on their own, these metrics may not seem particularly useful, but when they're combined they can be used to calculate metrics such as the HIS vocabulary metric for both a function and file. So if we now switch to the flat view rather than the hierarchy view, so in the flat view we can see all of the entities of the particular type listed, and we can see the metrics for each of them as we click on each entity. We can see whether the metric is getting larger or smaller. I think by now our other snapshot has been uploaded, so we can click on that and get a more of an idea of the change over the time of the project. So let's go and have a look at how we configure the metrics. So QA Verify calculates the metrics, the compound metrics, based on metrics from QAC++ and message counts, and can even calculate them on data imported from third-party tools such as testing tools, for example code coverage. Here's the formula we have for our vocabulary for the files. Let's now add a metric that will calculate it for the functions using the new metrics that have been added to QAC++. So the formula is a spreadsheet type formula, and we'll enter that. And we'll also put in a description as well. We'll also go and select what we want the metric to apply to. We'll make it apply to functions, and the rank will tell us where it will appear in the list of metrics. We can check that our formula is correct, and then when we click Save, QA Verify will now go and calculate that metric for every function in every snapshot in the database. So every snapshot that has been uploaded will have the metric calculated for it. So we can derive new metrics, enter them in QA Verify, and it will be calculated for the entire history. It takes a little bit of time to calculate the metrics. So now we can go and view the metrics that have been calculated by going to the measurement analysis page, and we can go and have a look at the functions, and we can see our metric is at the top of the list, and we can have a look at the metric for all of the entities that are there, and we can see the trend changing the metric as we click on each one. Now we might consider these metrics to be important, so we can add them to our project dashboard, so that when we log into QA Verify we can instantly see the latest metrics. So I can add them here. I'm going to add a project metric trend graph, and it's for the UCommon project, and we'll just pop in a title to describe what the graph will show. So we will have the file vocabulary, and we'll generate that for the entire history of the project. I could choose to just generate it from the last week or month or particular date range, but now I'm going to generate it for the whole project. So instantly when I look at QA Verify, my dashboard, I can see the graphs that are interesting to me. There have been many debates about metrics and which metrics are important. QA Verify lets you create and look at the ones that you consider important, and more importantly lets you track them over the lifetime of the project to see the trends. This can be used as part of an early warning system to monitor a project's health, allowing remedial action to be taken sooner rather than later.